Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest, and throughout this whole month we've been featuring some interviews with people who know and are friends with our industry icon for 2020, David Drake. But today we have an interview directly with him. He is the Vice President of Innovation for SmartCover Systems. Yeah, thanks so much for being on the call, David. We appreciate you taking the time.
Most welcome.
Yeah, and also congratulations on
Yeah, looking
being
forward
our
to it.
industry icon this year for 2020. We're very big congratulations to you for that title. What's it mean to be awarded something like that?
It's an astonishing surprise. I mean, it just kind of came out of nowhere. We talked about it a little bit, but then all of a sudden, one morning, it happened, and it's really extraordinary. I think the first reaction I had to it is that it causes me to have another duty, another obligation to do the outreach, and to kind of be the voice of water and wastewater to our industry and to frankly whoever, because it just is always taken for granted, and we need to be able to put more of an underline under the importance of it and how we need to invest in it, and frankly what we need to ask of ourselves. And those are things that just kind of struck me right immediately.
Yeah. Well, and you talked about in our first talk together about kind of the role and the importance of um, being an expert in two areas so that you can be an ambassador, basically. And it sounds to me like you're really taking that to heart with this in particular.
I am, and there's a lot of outreach to both the hard electrical engineering side and the water and the wastewater side. And the people that have talked to me since have been very interested in what the process has been, and how did we invent this? How did that work? Why didn't you try this? And so there's a lot of general interest in solving the problems that we solved, and also how to make it just more usable and accessible to people. And that's a very positive thing for me.
Yeah. Well, and just like looking back on your career, I imagine SmartCover is one of the good memories that you have. But what are some memories from your career that are most memorable to you that you're willing to share?
Oh, geez, I worked at several different places. One of them was Mitchell International here in San Diego. And at the time, they were really the preeminent automotive repair, documentation, and support center and software center. And what I did there was to help take them from very old legacy computer systems to much more modern new systems, and took what used to be a 2-day period of closing each month down to 2 hours. And so that vastly affected and improved the life of everybody in finance. I mean, it's not a really, earth shaking thing, but it was them, for them it was. And so that was memorable. I worked for Digital Equipment for 10 years. And at Digital, it was tremendous. It was a marvelous place to work. You got to visit every employer in town. You heard their problems, you heard their concerns, and you could do what you can to adapt to what they needed to succeed with. But also you saw what happens when management doesn't work right. And occasionally that happens. And so sometimes as a computer kind of a person, you become the second channel of information where somebody kind of down in the middle of the organization says, this is our real problem. And you get the job of communicating that to the big boss. Goes, oh, yeah, I hadn't heard that. So that was a lesson right there, about the value of communications and what happens when there's what I call communication skew, when one source of information and another source of information come at different times in different contexts, and people get confused.
Mhm.
And so what happens is, if they are confused, they can't make decisions. And that's one of the findings you have in a lot of public water agencies too. If they don't have a good strategic plan, if they haven't challenged themselves by saying, what is our mission? Then when they get challenged by a new thing, they get paralyzed. And so
Mhm.
how do you help people get through that decision point? That's a startling thing. So that, you learn one thing everywhere I go. I never take a job that I know how to do. I always take a job where I have to learn, and it's worked out for me. I worked for SCIC for about 5 years, very good company, and learned a great deal about healthcare, and some of it frightening, about how much money can be burned up in bad projects, and
Mhm.
those kinds of things are a lesson also. Not when you really want to learn, but sometimes you have to learn to get through the challenge. Um, I worked at the Jet Propulsion Laboratory, which is one of my favorite jobs. And I think there were a couple of major projects that I worked on that I resolved issues that were extremely difficult. And the jet lab was like that. Everywhere you turn, you're getting a new challenge. I mean, you're surrounded by 4,000 PhDs. And so everybody's got questions, everybody's got challenges. And so you'll learn very quickly. But one of the things I learned there was you could not be promoted until somebody else died above you. And so I wanted my career to move a little faster. So that's why I left the jet lab. But it was, I'd still be there. It was a marvelous place to work where you go there and your boss says, well, we're going to go to Mars now. Let's figure out how to do it. Let's go, you know? And so it's the places that would be a dream for other people is a hard reality. And you're banging rocks with hammers. Things are happening because that's the reality of the jet lab. It's an
Yeah.
extraordinary place to be. So you think about things you learn and questions you go through. So when we finally started the SmartCover Corporation, we started it as Hadronics Incorporated, and we had created the trademark SmartCover. We do business under SmartCover,
Mhm.
but the actual company underlying name is Hadronics. And when we did that, both Greg Quist and I came with a lot of knowledge about how to fail, how organizations struggle, how they didn't get it done. And I think what we did that was unusual and unique was to truly identify what our clients needed and to answer that need question rather than creating a widget and trying to sell it to somebody. That doesn't go very far. But that if you can help them solve their overall problem, that was compelling for me.
Yeah. It was about finding that concrete problem to give a concrete solution to,
Yes,
basically. Yeah,
yes,
well, I mean,
indeed.
touching on the smart cover side of things, obviously you've been working on solving this problem. Why is this industry so important to you? And moreover, like, why is this problem such an important one that you think needs to be solved or needed to be
Back in
rather?
1990, I became sure. I became involved in local government, and I kind of formed a strong commitment to public service. And so I learned about water first and potable water, and then in 2005, we became in contact with the wastewater problem. And when I started to realize how important it was, it really it caught my eye. And well, some of the things we didn't know at that time when we started, we realized we could save people money, we could save people time and effort and bad pollution. But what we didn't know at the time was that the EPA said that for every sewer spill, you get about 150 human infections, either from the beach or from people walking through sewage. And I thought that was an overestimate. And then I actually saw some real sewer spills, and literally the stuff is getting up on the sides of cars and wastewater is going everywhere, and little kids are riding bicycles through it. I go, you know, that's probably not crazy. It probably is about 150. And we've prevented probably close to 30,000 sewer spills. And that would be 4.5 million infections. And if even 1 in 100,000 infections was fatal, we've saved 45 lives. And so as time moved on, we realized we were saving lives every year. And that becomes very compelling. And you realize the importance of it and communicating the importance of it for making sure that people are operating wastewater systems well and that they're not being damaged because of what's happening in the environment or what happens in collection systems. And so if we could help mitigate that problem, that was a huge win. I mean, what's the value of 45 lives? Frighteningly enough, I could tell you.
Yeah,
Depending, it's about five.
it
Go
seems
ahead.
intangible to an extent, right? Like it's
Yeah.
hard to measure something so intangible.
Working with the JPIA, you actually evaluate things like that depending on age and skill and background and such. A teenager is worth about $7.5 million.
Wow,
I mean, you actually quantify it.
that's crazy.
And a typical average adult was about 4 or 5 million these days. Back in 9/11, which tomorrow is actually going to be the anniversary of that,
Mhm.
they actually evaluated at about $2 million a person back then for the loss of their
Wow.
life. And it's a hard thing to think about. But how do you quantify risk and quantify lives saved? And that sometimes you have to do that.
Yeah, yeah. Well, going a little bit back to what you were talking about before with the Jet Propulsion Laboratory, there was some mention of this in the
Yes.
article that I was able to write and stuff, but I wanted you to go a little more in depth about your experience there and kind of how that informed your future, because it seems like it was pretty formative for you in a lot of ways, gave you some knowledge and just seemed like a
Oh
really
yeah.
exciting time for you. So, would you care to share a little bit more about that experience, what that was like,
It
how
was.
it involved you as a
I,
person?
I was there from 74 to 79 years ago, long before you were born. And it was a tremendous experience. And everywhere you turned, you learned. You had to learn. It's a place for continuous learners. And I worked initially on a blood cell analysis system because they were trying to evaluate the effect of radiation on astronauts. And it turned out they defunded that because they didn't necessarily want to know the answer. So it was an odd situation. But I moved over. The one thing I had done, I also learned about optics and radar. It's almost the same mathematics. So I moved into synthetic aperture radar in building 183 on the seventh floor. And it was a marvelous organization to work with. And we were flying aircraft where the cargo doors were replaced by a radar antenna, and we could image the ground like a hologram using microwaves. Then that same kind of technology was placed on board the CSAT satellite. That's SEASAT. Was launched in 1978 on my birthday, and you could still look it up. And I helped select the antenna for that spacecraft. But the signal analysis for it and the sophistication of it was extremely high. And organizations, I won't name them by name, but one of the other major giant aerospace corporations tried to do what we did. It cost them $1 billion and they failed. We did it for 55 million bucks. We put together the spacecraft, the transmitters, the receivers, the antennas, launched it on a $25 million Atlas F. It was the first rocket launch I ever saw up at on Point Mugu. And it was a spectacular success. The satellite operated for 99 days and then mysteriously failed. And it turned out it failed because of slip rings that were drawing power from the solar panels, and somehow they'd failed. And the contractor who saw this said, "Oh yeah, we had an ECO for that. We forgot to put it on there." And so they were blackballed by NASA for 5 years.
Oh
So,
my.
but it was a sad circumstance to lose the data. But that several months worth of data is still used today and analyzed and reanalyzed for observing the ocean and things like what's the age of ice in the Arctic, how much ice coverage is in the Arctic, things you'd never think about. If you have ice layer on the Arctic, it transmits 1/20th the heat from the ocean to the air. Cover it with ice and it drops it back down again. So it has a huge effect on weather. I mean, that's just one of 100 things that we were looking for. And wave heights and geology. And then on top of all that, Charles Alachi, who was the eventual director of the Jet Lab, was involved in an archaeological experiment, and they found underground cities under the very arid soil of the Middle East. I think the city of Ur, if I remember right, was one of those that they discovered the roads and structures 20 feet under the soil, invisible to everybody, but the radar could see it. And so, I mean, that was a earth shaking.
Yeah.
And so that synthetic aperture radar came forward and eventually became part of what was called VOIR, the Venus Orbiting Imaging Radar, which became Project Magellan. And for the first time, we could ensemble look at the entire planet of Venus underneath its cloud layer. And I was one of the last things I worked on was VOIR data. And so the team of people that did extraordinary work on historic stuff. Even today, if you were to buy a globe of Venus, it came from Magellan. So
that's incredible.
I could go on for hours, but it was extraordinary. Radar, synthetic aperture radar, one of my good buddies, Mike Kobrick, recognized that if you looked at the space shuttle and managed the radar just right, you could image the whole Earth in a few days of orbits and create an incredibly accurate geographic measurement of the height of the land above sea level, which had never been done on a worldwide basis. And there are aircraft that flew into mountains because they didn't have accurate topographic data. This data became part of a major effort within the FAA to better characterize our airspace environment. I mean, just one thing after another.
Yeah.
So I don't want to go too far, but just to let you know, the place was magical and is today. I mean, when I see those robots running around Mars, I go, man. And
Yeah.
just
So cool,
impressed.
right? Yeah,
Oh yeah. Oh yeah.
one of the things that I really latched onto for you is that you have such an interest in obviously like space and outer space and that kind of thing, but you also have this interest in like going deeper into the earth. Like you're the extension of understanding. You're always
Yes.
looking to understand the boundaries that we're currently at and how can we push that boundary out further. Um, like what is it that drives you to be like that? Like what is the is that just innate curiosity or is there something more to that?
Yeah, but pathological curiosity. And I think sometimes it's the discovery of subtle effects. And I'll give you an example. Chicago, wastewater system in Chicago around the year 1900, for some reason started running backwards. And if you're familiar with wastewater systems, they're actually almost level. They're designed to move, I think it's 2 feet a second when they're actually flowing water, but that means that they're level almost to within a 1 part in 10,000. Well, from time to time, as we're sitting here in our chairs, the moon and sun go over and the earth moves up and down about 20 centimeters. And it's called an earth tide. And if you look in detail, you'll find that sometimes the earth tides actually counteract the slope of a wastewater system. And all of a sudden you get water running backwards and you go, how the heck is that happening? Well, that's why. I mean, that's the subtlety that isn't obvious,
Mhm.
until you start understanding a little bit about the physics of the earth. And it's extraordinary when those things happen. And it took wastewater to discover it. No one ever observed it before.
Mhm. Yeah, and that gets to the whole point that you mentioned in the article that I wrote about transforming that type of beauty into insight, taking those really
Yes,
beautiful moments of nature and turning them into insight that can solve a problem. So,
yes. And the problems are subtle. They're not always so obvious. Now, then again, you take a 3-ton fat burger from London, the size of a Volkswagen, that's not so subtle.
yeah, the
And
fatberg
so
saw my
that
work.
that kind of, oh yeah, the super fog, events are extraordinary. What's amazing is sometimes you can operate for years under very diminished circumstances, and then you suddenly realize how badly off you are underground. But it
Mhm.
takes measurement to do that, and that's kind of why we got involved in this thing.
Yeah. Well, thank you so much for taking your time to talk with us today. Is there anything else that you wanted to share with everyone before we let you go?
Be brave. I would say, do your homework. Um, Learn as much as you can about the challenge of water and wastewater, and think about the fact that every drop of wastewater today is tomorrow's supply of water. Especially out west, we need every drop. We call it circular water. The water comes to the wastewater system. It's actually much cleaner and lower in salinity than the ocean water. So do what you can to reuse it. Reuse every drop twice and 3 times. In the center part of the United States and the East Coast, we often have too much water. So the obligation is more, how do we take that excess flood water in the spring and put it somewhere like the Ogallala or other places that really need water? And so the challenge for water and wastewater professionals is how to best use the water and then make your voice known. It's not going to get out there unless you tell people about it, and then it becomes more obvious. So I'd say be candid and be accurate.
Yeah. Well, congratulations again. It's been an absolute pleasure to talk to you and get to know you over the past month or so that we've been talking, and I'm looking forward to many more conversations with you. So.
Bob, total pleasure. Thank you.